In this section, we're going to talk a little bit about risk analysis and basic security practices in cloud providers and how you can identify problems and benefits in using cloud-based technologies. So the first thing you want to think about is risk analysis. And if you're currently using a non-cloud product like some sort of traditional desktop software, then you have to consider the risk of switching to a cloud-based approach. All of the processes you may have designed around a traditional desktop software have to be questioned as to whether or not they still make sense in a cloud-based situation. These are things that you really need to understand before you make the switch and not something that you want to discover after having made the switch. This is a list basically from the textbook, but I would actually add to this user and stakeholder opinions, which is not mentioned in the textbook, and that's why it is bold-faced here. Your users and stakeholders also have security risks, privacy risks that should be considered, in part because it will affect your bottom line, right? Ultimately, the users and stakeholders, the people who have an interest in the success of the project, are going to have an economic impact on whatever system it is that you're doing. Regardless of whether or not their risk analysis for your organization pans out. And it's worthwhile to think before you make the switch about what your users and other stakeholders may say about switching. So this risk analysis is actually fairly similar to what you would do in a traditional desktop environment, but it has to be redone if you are switching to the cloud. So in both cases, you want to identify your assets, figure out your vulnerabilities, and look at the likelihood of exploitation, the sorts of things that we've talked about to the semester up to this point. The difference is that when you switch, the analysis changes. And unless you go back and redo this sort of analysis, you're not really going to know what sort of security position you're in by switching to a cloud provider. That said, there are some things that do change in terms of how easy they are for you to compute, right? Basically, how do you pick a cloud provider in order to assess their encryption options, the authentication options, the incident response capabilities, and how they may change associated with working in a cloud environment. And so when you're trying to figure out how to make the switch and who to go with, you need to figure out all of these considerations for whatever provider you're switching to, right? So one very good example, I think, is the legal consideration. For a long time, it was not possible to find a cloud provider that would sign a HIPAA Business Associates Agreement. Now there are many options. Similarly, I think GDPR requires downstream processing agreements put in place for cloud providers that you have as a part of your overall solution. So for example, if you were doing business in the EU, you can't just transfer data from the EU to a cloud provider in the United States without having some sort of business agreement with that organization that transfers liability through the GDPR. There are resources to help with this assessment. I think maybe the best two are the FedRAMP standards at fedramp.gov and the PCI DSS standards, which are actually an industry standard for the payment card industry, essentially credit card industry. Those are organizations that have been doing this kind of assessment for a lot longer than many organizations. But the stuff that's come online in the last decade or so, in particular the Cloud Security Alliance recommendations, the STAR recommendations, are becoming more mature and I think reasonable things that you can use. I don't know that you have to use one of these tools or resources in order to make this assessment and to do it well. But if you're starting at an organization that doesn't really have a process in place and you're like clamoring as the new person, hey, why don't we make this a more systematic assessment of our security posture, these are great places to start. When you switch cloud providers, you have to consider the cost of switching from one provider to another, as well as just the cost of staying with your original provider. So you may not be in a situation where you're starting out with desktop-based software, non-cloud-based software systems, and switching to a cloud provider from scratch. You may actually just be trying to figure out whether or not there's a cost savings to switch from one to the other. This also requires a bit of security analysis because when you do switch, the options for security may change. So you can kind of go all the way back to this risk analysis we had previously, right? Going through the assets and vulnerabilities. You may want to do this all over again from scratch. But in addition to that, you do want to consider like the backup concerns and some of the other issues that are going to be associated with switching from one provider to another. This typically happens when you're going up or down the stack, right? So if you are starting out with a software as a service provider, and you're trying to migrate away from them so that you can own more of the system, either by switching to a platform as a service or infrastructure as a service. Maybe your needs have expanded and the software as a service that's being provided to you is no longer fine-grained enough detail or doesn't offer you enough control. In that case, your only real option is to go to this platform as a service scenario. It's hard to do. It's very challenging to do this, and you do have to consider from the beginning. You're going back through all of the risk analysis that we had mentioned previously, the kinds of things that you have to do to figure out what your security position looks like when you do that change. But in addition to that, you're going to have to figure out how to do the transition itself, right? How do you take the backups from one environment and make them available in another environment? Particularly if there's like legal agreements that you have in place to maintain customer records for a period of time. All right, so there are security benefits to switching to a cloud service, whether you're going from a desktop system or from one cloud provider to another. The main one is geographic diversity, right? Your cloud provider is going to almost automatically back up your data in geographic locations all over the world and mirror this data so that you'd always have access to it. You're never going to be beholden to a single natural disaster, a single local problem, or anything like that. That can be problematic from a legal standpoint, and I would point to the GDPR here again. It's very difficult to put in place a contract that restricts geographic diversity for cloud providers when the whole point of the cloud is to make sure that you have this data all over the world and readily available in a way that you're not going to lose if there's a disaster. Another important benefit is you're going to get diversity for free, right? Different platforms and infrastructures mean different bugs and vulnerabilities. Most cloud services are using very large, complex systems with a significant investment in terms of different infrastructure. So your cloud service as a part of a larger system can actually be an incredibly good way to diversify your technology stack. It also is shifting some of the platform and infrastructure risk to the cloud provider. This is actually one of the things that you're paying for. You're getting their benefits, the benefit of their work for maintaining this reliability and security that you would not have to do on your own. Another way of thinking about it is through that availability piece of the security triad, right? Confidentiality, integrity, and availability. Cloud providers are really just providing availability. And so from a security perspective, they're going to be doing that. They specialize it. They're going to be doing that much better than you at your organization on your own. All right, cloud-based security functions. Often when you switch to the cloud, you can basically outsource the entire security problem. A great example of this is something like email filtering, right? Because it's already basically a cloud environment. We don't really think of this as a security benefit anymore. Almost all the email filtering happens somewhere in the cloud. And by adopting something like Gmail as your organizational email client, you're never really going to have any email filtering on your own organization. You've literally outsourced the entirety of that security problem to your email provider. Now, you may actually add contractual obligations for what happens if something does get through, what happens if there is a problem. And that's true for not just email filtering, but all of the other concerns here, denial of service attacks and network monitoring attacks. But you're still outsourcing it. You're still essentially sharing the risk with the provider and making some sort of contractual agreement as to liability with the provider to take care of these security functions. So let's talk briefly about distributed denial of services protection. You can actually pay Cloudflare and other cloud-based distributed denial of service protection services to maintain and update DNS records so that you would not actually be easy to target from a distributed denial of service attack standpoint. They handle all of the bandwidth issues, they handle all of the incoming traffic issues, and your organization is simply paying them to do this. So they're better at that sort of problem anyway. They're better positioned to address that sort of problem anyway. So it's actually a win-win for both them and for you. And then for network monitoring, cloud-based solutions really do help customers in ways that you can't do in a traditional environment because they have much more control over their hardware requirements than organizations would. A good example of this would be something like the Heartbleed bug, or not the Heartbleed bug, the meltdown, the Spectrum meltdown stuff, where if there are processors that have significant security risks, then the cloud provider that you're dealing with can actually handle those in a way that your organization almost certainly can't because of scale. So, for example, if you only needed 10 servers and they're a significant part of your budget for a small startup, just replacing them at the drop of a hat is really, really hard. But if we're talking about Amazon, replacing 10 servers is not really ever a concern. They have, first of all, the money to just buy and replace those straight up. But for them, the problem looks a little different. They have thousands and thousands of servers, and it's a huge issue. It's the kind of thing that they would be better positioned to go to companies like Intel and AMD and say, look, this is a terrible problem. Can we work out a deal where you can provide us chips so that we can replace these servers, or provide us patches so that we can fix these servers much more readily than any individual would be able to do on their own. And then finally, for this section at least, cloud storage. We really want to talk about what does it look like to store data in the cloud, in part because that's the traditional earliest use of cloud. It's to store user data rather than to do all of the compute stuff that happens in the cloud nowadays. And it's still by far the biggest use of the cloud. People want to store data in the cloud, make it available all over the world, even if they're doing the computational piece on desktops or on their own systems. Most of this data is going to be stakeholder data of some kind, either user data that's being stored for the rest of the organization, or data that's like generic business data that would be eventually processed for use for customers. Now, storing this stuff is a little bit complicated, and much of the rest of the next section is about models for dealing with those stories, dealing with that storage. I just want to highlight right now that the key concern that you should look at is how do we store this data efficiently, okay? And this is one of the reasons why we'll be going through a number of trust no one models, which are these models down here, the TNO models, right? We'll be going through quite a bit of that in the next section. But the key reason that we're doing this is it's much more efficient to store data in an unencrypted fashion than it is in an encrypted fashion. Okay, the best example of this is Dropbox. They have checksumming features that allow them to detect when a file is uploaded, and then for every other user that uploads that file, they don't have to store it. They can just point to the original source. So for example, if I were to provide you each with a PDF of the syllabus, and then one of you uploads it to Dropbox, the first time it gets uploaded, it's actually uploaded. The second time it's uploaded, what Dropbox does is they will create a checksum or a hash of the file, compare it to their giant list of every file that's ever been uploaded to Dropbox. If they find a match, meaning if somebody else has already uploaded the file, they don't even bother with uploading it. They just point your file to that file, right? Because the cryptographic hash says we already have an exact duplicate of this file somewhere in our system. And that means that we can save storage space by not uploading this file wherever it is and just using whatever the original version of it was, right? So it's much, much easier to do this on unencrypted data than encrypted data, mostly because the hash scheme no longer works if you encrypt the data. Remember, if we encrypt the data, it essentially looks like a random set of ones and zeros, because every time you encrypt it, it's going to be producing a different output, right? So whatever encryption process you use, as long as you're using a new key, right? You should use a different key for every one of your users. You're not going to be able to do this deduplication is what it's called, this process of identifying whether or not you already have a file somewhere on your server. Now, this is problematic from a security and privacy standpoint because knowing that this is how it works, I could basically provide all of you with the syllabus, and then you would know if you were the first person to upload it to Dropbox, right? Because you could watch your network traffic and you could see, oh wow, it's actually uploading this file, as opposed to some small crypto checksum of the file, and that would tell you at least a little bit of information about the rest of the class, right? So you can imagine problems where this is actually more serious than somebody uploading a syllabus, like if it was healthcare records or something like that. That's the sort of thing that you would be in a better position to detect as a security concern, right? Because if I'm uploading your health records before you are, and then you go to upload your health records, you know somebody else has already put this stuff in Dropbox, and was that actually intended to be put in Dropbox or not? Those are the kinds of security issues that a deduplication system would, very, very basic security issues that a deduplication system would identify for somebody. Now, some cloud services do provide more confidentiality by doing this on a per user basis or per organization basis, meaning essentially if UMBC had a contract with Dropbox, every file that UMBC uploaded would be considered separate from Dropbox as a whole. And in that scenario, you'd only really be able to detect if somebody else at UMBC had uploaded a syllabus, or uploaded a particular file. Now, for maximum confidentiality, you wouldn't even have that organization level trust. We would go with a true trust no one model in which everything is encrypted and even the provider doesn't actually have access to the keys. A good example of this is something like Spider Oak, where every user has to have their own encryption keys and the data is always encrypted prior to even being checked for its existence on the cloud-based server storage unit, whatever it may be. So in the next section, we'll talk a little bit more about how these trust no one models work, the kinds of benefits that they produce.